This is a 1600 kilogram car. Now, how much applied force I have to exert on it so that it will accelerate at the x direction? When I apply forces, so how much? What is the minimum force I need to apply so that this car will accelerate at the x direction? Understand that this is rubber on concrete. 0.9 for rubber on the concrete. Alright, so the first thing we have to do is the free body diagram. So this is the car. Two forces acting on the car, well actually three forces acting on the car. This is mg. There are two components of this one. So this is Fa. So Fa has two components. So Fa has two components. F cosine 30 degree and F sine 30 degree. So this is F sine 30 degree. So normal force is all along. So normal force is mg plus F sine 30. Minimum applied force needed to accelerate the car at x direction. Okay, so then the applied force at the x direction has to be greater than or equal to the force of friction. So what is the applied force? Applied force is at the x direction is this one, F cosine 30. Force of friction, the equation for force of friction is mu s Fn. Alright, so we're going to write mu as Fn. Now notice that Fn is mg plus sine 30 degree. So F cosine 30 is greater than or equal to mu as F sine 30. Mg plus F sine 30. Mg plus F sine 30. Okay, now I'm going to factor out, let's being the F sine 30 to this side, so negative F sine 30 degree and mu s is equal to mu s mg. So factor out F, so cosine 30 degree minus sine 30 degree mu s is equal to mu s mg. Now finally we find F, this is not equal to, this is greater than or equal to. So F applied force at the x direction has to be greater than or equal to mu s mg over cosine 30 degree minus sine 30 degree mu s. So mu s is 0.9 and m is 1600, g is 9.8, cosine 30 is about 0.87 minus sine 30 is 0.5 and 0.9, so it's 34613 Newton. So you need 34,613 Newton. On the car, the friction on the car is 0 because I'm applying 0 force. What is the friction of the car right now? The friction of the car is now 10 Newton because I'm applying 10 Newton. Friction of the car is 100 Newton because I'm applying 100 Newton. Friction of the car is 200 Newton because I'm applying 200 Newton. Friction of the car is 4,000 Newton because I'm applying 4,000 Newton. Friction of the car is 35,000 Newton because friction of the car is 34,000 Newton because I'm applying 34,000 Newton. Friction of the car is 34,612 Newton because I'm exerting 34,612 Newton. So even with 34,612 Newton, I won't be able to move the car. But if I do exert 34,612 Newton, the force of friction acting on the car is 34,612 Newton because the ground increased the friction to 34,612 Newton to keep the car at rest. However, if I somehow magically can apply 34,613 or more Newton on the car will accelerate. Thank you.